Audio Jungle.
Hi, Assalamualaikum dan selamat sejahtera. My name is Muhammad Yusuf. My matrix number is CE190029. So, today I will explain about the calculation of this lab. So, design a battery charger, a boost converter to provide an output voltage of 24 volt from a 12 volt source. The load is given 50 watt. So calculate the duty cycle for the equation operation. So as you can see, so this is the equation. V output equals to V supply divide by 1 minus duty cycle. So the equation is they want the duty cycle. So P equals to 1 minus V supply over V output. So just insert the information that was given. So 1 minus 12 divided by 24, and we got is equal to 0.5. So question 1, we proceed to question number 2. Determine the resistance used for given output power 50 watt. So we refer to the formula. So P output is equals to V output square. It divide by resistance. So the equation want the resistance or the resistance is used for the given output power. So they already given the output is 50 watt. So R equals to V output square divided by P output power output. So you just insert the key in the information was given. So V output square 24 square divided by 50 and equals to 11.352 ohm. So the resistance is 11.52 ohm. So we continue to the next question. It's question number 3. If the switching frequency is set to be 20 kHz, calculate the minimum inductor parameter. So we found that L, a formula of L minimum, L is equals to T duty cycle in bracket 1 minus T and close bracket square T times R divided by 2. So we know that T is equals to 1 over F, or F equals to 1 over T. So T equals to 1 over F. So we just design it, write it down back. T equals to 1 minus 2, 1 minus D square times resistance R. So divide by 2 frequency F. So just key in the information that was given. So L equals to 0.5 times 1 minus 0.5 square times 11.52 ohm and divide by 2 times 20k. So and after calculation, you get that 36 microhenry. So that's all for me. Thank you.
Hi, my name is Shumpaka Amali binti Mahazi. My metric number is DE190193. I will share with you about the discussion answer for the question of IV and V Romans. Based on the IV question, it states that what will happen if the inductance value is set to be less than L min. The answer is, if the inductance value is less than L min, the inductor current does not flow through the entire cycle and reach zero much sooner, even before the period ends. The inductance of the discontinuous condition mode is less than the minimum inductance. Next, for the fifth question, if the ripple factor, which is R, is set to be less than 1%, specify the value of capacitance. To find the value of the capacitance, we use the given formula, which is R equal to D over RCF, where D is the duty cycle, R is resistance, C for capacitance, and F is frequency. So we rearrange the formula and make C as the mean, and we will get C equal to D over RFR. Substitute all the values that we have get from the previous answer calculation. As the result, the capacitance values when the ripple factor is set to be less than 1% is 217 is 217.014 mu f.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Hanif Hakimi bin Azlan and my metric number CE190063. I will continue explain about the lab activity for the question number 6 and number 7 Roman, which is for number 6, which the given specification and all calculate value from the 1 to 5 Roman and construct the model of DC to DC converter using MATLAB simulation and plot the duty cycle, inductor current and output water ripple as shown in finger form. And for the number 7 question is increase minimum inductor by about 10 times to ensure full continuous mode and execute the simulation with new inductor and feed the table that given in question. So the tool that we use in this simulation is MOSFET, DC voltage source, voltage measurement, current measurement, pulse generator, scope, power GUI, series RLC branch, and then other required blocks such as go to and from. So this is the simulation that we have already done. So this inductor, capacitor, resistor, MOSFET, PWM generator and duty cycle, and this for the waveform, and this for the result output voltage. So we have to insert the value of inductor, capacitor, resistor. So the value of resistor is 1.53 ohm, capacitor 217.01 microhenry, inductance 36 microfarad. New inductance for the question 7 is 360 microfarad and DC voltage source 12 volt. So after we insert the value for this simulation, we set the duty cycle for 0.5 and stop time 0.05 and then run. So after we run, we get the result for the output voltage is 2.95 and for the waveform, this is the waveform for the current measurement. For the result waveform, this is the current measurement, voltage measurement and PWM generator. So what we can see here, the maximum inductor current is 8.047 and for the minimum inductor current is negative 2.151 milliampere, and for the average inductor current is 8.059. Okay. For the question 7 Roman, we need to change the inductor from 36 to 360 microfarad. So we change. Okay, then we need to change the duty cycle 0.1. We need to solve the results, the output voltage for the duty cycle 0.1 to 0.8. So we get the result. So okay, next for the question 7. Okay, this is the result that we get for the question 7, which is voltage supply. We insert the voltage supply for 12 volt, duty cycle 0.1 to 0.8, and then this is the result for the simulation and this is the result for the calculation. So what we can see here, the small difference between this calculation and simulation. For the duty cycle 0.1, we get for the calculation 13.33 and for the simulation 12.53. For the duty cycle 0.2, 50 and for the simulation 14.18, 0.3 17.14, and for the simulation 16.3. For the duty cycle 0.4, calculation 30 calculation 20, and for the simulation 190.08. For the duty cycle 0.5, calculation 34, and simulation 22.9. For duty cycle 0.6, 30, and simulation 28.43. For 0.7, calculation 40, simulation 36.95, and last one for the 0.8, 60, and simulation 50.79. So this is the formula for calculation. We solve the output voltage, which is VO equal to Vs over 1 minus D. Okay, that's all from me. Thank you so much.